Hello, everyone. Welcome to our shop talk this week. Glad to have you with us today. Our shop talk series is our way of easing you into the weekend, designed to be an informal, off-script, uncensored discussion of emerging technologies. We started the shop talk as a way for our researchers and consultants to meet virtually and share ideas. We wanted to cross-pollinate both sides of our business and reconcile what's trending from our researchers with what's practical and realistic from our consultants. Then we thought perhaps you in the audience would be interested in listening to these conversations and even participating in them. So we've opened it up to all of you, so welcome. Just a little background on Eckerson Group webinars. We have a full slate of them. Two different types. We have these shop talk webinars with a very short presentation to kind of kickstart and prime the pump on a panel discussion. Our community forum webinars are a little bit more traditional, sometimes sponsored, with a longer analyst presentation. And you can see all the fine topics that we have coming up in the next month or so. Data analyst workbench, data fabrics, going from data laggards to data elites, business monitoring. So I hope you can tune into those. You can sign up and register for most of those right now, I believe, on our website under the webinar tab. And just a little bit about Eckerson Group. We are a research and consulting firm that specializes in data and analytics. That's all we do. We have three parts to our company. Research, and I bet a lot of you have read our reports and articles on our website. We have a consulting arm that helps end users develop data strategies, among other things, and we do a lot of education as well on these topics. So these are our panelists today. Our researchers are on the top. Unfortunately, Jake could not be with us today. And on the bottom are our consultant team, and Mike is not with us today. And we're fortunate today to have two guest panelists, experts in DataOps, Chris Bergh from DataKitchen and Guy Adams from Datalytyx. First, we want to push a poll out. So Deb, do you want to put our first poll up there? We want to ask you about DataOps. Does your organization have a DataOps strategy or initiative in place? Very simple, yes, no, somewhat. I will give you 5 seconds to click one of those. And then Deb will close it and we'll show the results. And then we'll compare it to a survey we did last year and see if we've made any progress. So Deb, why don't you go ahead and close that and show the results. So it looks like yes, 19%, no, 45%, and somewhat 36%. That's pretty comparable to what we had. So let's see. So when we did this last year, we had a few more saying yes, 27%, though I believe it was 19%. So looks like we've gone a little bit backwards, but maybe not a fully representative sample. And the folks that responded to that survey last year were largely BI and data warehousing managers or IT architects at mostly large firms. Okay, so let me start my slides. I'm going to start with 10 symptoms, because a lot of people don't know what DataOps is. So we thought maybe it'd be better to talk about what happens if you don't have DataOps. What I want you to do for each of these 10 symptoms, just make a check mark or keep a record of how many of these apply to your organization. And I want you to total them at the end, and then we'll do another poll. So number one, your data team is flooded with request tickets and is burning out. Number two, business users don't trust the data you give them. Number three, source system changes keep breaking your ETL jobs and data pipelines. Number four, you use business users to debug data quality issues. Love that one. Number five, this happens all the time, data analysts recreate existing data pipelines with minor variations. 6, you have difficulty meeting SLAs. 7, data scientists wait for months for data and computing resources, or maybe weeks. How about that? 8, your company can't figure out how to migrate workloads to the cloud because they can't figure out what the workloads are. The data pipelines are too complex. 9, you're too consumed with data fires to implement predictive analytics or any other value-added solution. And finally, number 10, it takes months to deploy a single predictive model. As you can see here, there's use cases for DataOps across the spectrum. But Deb, why don't you put up our next poll, which is going to ask people to tally up how many symptoms apply to their organization. So 0, you guys are truly DataOps pioneers. 1 to 3, 4 to 6, or 7 to 10. We'll see how much our audiences need of DataOps help. Okay, Deb, why don't we close that and put up the results. All right, looks like 4 to 6 has the plurality with 50%. 7 to 10 shortly behind, and 1 to 3 behind that. No one has none of those symptoms. Well, good. So we have some work to do, obviously. So let me just kind of define DataOps, what it is, why you want to do it, and what its major components are. And then we'll open up the discussion to our panel, a distinguished panel, and take questions from all of you and maybe do another poll or two. So what is DataOps? There's many definitions out there, but I think one way to look at this is DataOps applies the rigor of software engineering to the development and execution of data pipelines. It's trying to move the whole process of creating data pipelines, data-based solutions from an artisanal craft to an industrial process that scales and is reproducible and maintainable and delivers things at high velocity with high quality. You can see on the left kind of the evolution of software engineering and now data ops or data pipeline development. It all started in the early 60s on the software side with cowboy coders. Single people went in there and built solutions all by themselves. Software jockey, making stuff up as they went, not reproducible, not scalable, hard to maintain, especially if the cowboy coder left, and slow as one person pretty much. And so the software industry realized that wasn't going to work. So we need teams of coders working together and doing so at high velocity and pushing updates out, not once every 3 or 6 months, but once a week. Now we see them being pushed out a dozen times a day sometimes. DataOps is a little bit behind, probably 10 to 15 years behind the software industry. We're kind of taking our cue from them, trying to mimic what the software industry has done to make code more rigorous, higher quality, and deliver it more quickly. We're trying to do the same on the data side. We're just a little bit behind. So we're taking our cue from the DevOps world. So what is it? So what would you do when you do DataOps? Well, there's a number of development practices, and these may not be all inclusive, and I hope our panel can help flesh these out, as well as maybe provide a better definition of DataOps. But the first thing we want to do is componentize our code. Instead of creating this large blocks of monolithic code that are hard to update and maintain, we want to break them into smaller chunks. So it's easier to update and fix if something goes wrong. And then for each of those chunks of code, we want to build tests up front that will test that code when we put it all together with the other code. Maybe 4 or 5 tests per block or chunk of code. And one big difference between DevOps and DataOps is that we have data. And in the spirit of DevOps, we want to treat data just like code. Rather than maintain a single version of truth in a data warehouse, what we want to do is maintain a single version of truth in business logic stored in metadata and then activate that business logic, which could be in the form of SQL and stored procedures, when we want to make a change to the data warehouse. We push that change out from metadata and with tests along the way to make sure the quality is still there. So that's the next one, drive changes via metadata, and also use that metadata when migrating from dev to test to production. And then finally, monitor continuously using the tests we've already built, run them as we're executing the code to make sure nothing has broken in the meantime. So those are some of the primary development practices we see with DataOps. And the benefits technically are we can deliver code faster with fewer defects. And because things are more automated, there's less rework and churn. People don't get burned out. And as a result, because it's automated, they have more time to focus on value-added activities. So the developers really, after an initial shock, because this is a different way of thinking and doing things, but after initial shock, they believe they can't live without this because it really liberates them. And from the business perspective, DataOps helps us really deliver on the holy grail, the promise of delivering data solutions faster, better, cheaper, which means we have a lot happier customers. Now, this is a framework I created a while ago to kind of give you a sense of the DataOps environment. The blue arrow in the middle is a typical data pipeline that takes data from source systems, ingests them, transforms them, and then moves them into a target environment where it can be consumed by any number of business users, from executives all the way to data scientists, and as well as applications. Above the pipeline, we see some of the DataOps processes. This is kind of new to most of us in the BI data warehousing world, where we're using continuous integration, continuous delivery tools to create that code, test that code, orchestration to manage the different tools that are pushing the data from source to target systems, and then continuous testing and monitoring. Below the pipeline are the traditional things that we've always talked about in the data warehousing world, from ingestion to integration to preparation, and finally to data analytics. And inside the circle are some of the core, I would say, supporting services. Like for DataOps, a key supporting service is a code repository, as well as a configuration repository and container management services. So that's kind of the big picture view of the whole spectrum of DataOps, the DataOps world. So getting to the question that this whole panel wants to discuss today is, where do you start with DataOps? It seems a little overwhelming. It's like boiling the ocean, right? Well, from the people that we've talked to who've done DataOps, organizationally, there's a few things you can do. One, educate your team. We've written a lot about this. There are folks who can come in and speak to your team about it, convey some of the concepts, maybe help them or allow them to listen to something like this. The second thing is get your team to identify the key bottlenecks that are slowing you down and causing pain, causing data quality issues, and then prioritize those bottlenecks, and then develop processes, and may require tools, maybe not, to break through those bottlenecks and develop things more quickly, more efficiently, more effectively. And also debrief regularly. A big part of DataOps is Agile, the Agile methodology, and a great part of Agile methodology is the debriefing that takes place at the end of every sprint. In the DataOps world, people tend to take that to the ultimate level. There's one team I talked to that does a debriefing sprint. So every 4 sprints, they take one entire sprint to identify bottlenecks, identify ways to break through those bottlenecks and improve their processes. So the mantra with DataOps really is to continuously improve. Now, from a technical side, we've already mentioned a number of these things. Start trying to componentize your code, break it apart, build tests for those code blocks, start treating data as a code, storing the logic in a repository, using the repository as a way to develop new applications and features, as well as change what already exists. And then you'll probably need to invest in DevOps or DataOps tools, code repositories, CI/CD tools, test management tools, orchestration tools, and performance management tools. So that's the end of my little spiel. But before we bring the panel on, there's one more poll question. Okay, so how long does it take to create a new data pipeline? I should say data pipeline. Does it take a minute to create a new data pipeline, hours, days, weeks, or months to create a data pipeline? All right, so let's close that poll, because I know you guys all know this by heart. And Deb, why don't you put up the results here? All right, days gets the plurality, followed by weeks. So that's better than it's been in the past. So I think we're making some improvement. Yeah, so it looks like we've improved a little bit from last year when we took this poll. Well, terrific. All right, so I want to reintroduce our panel. If you guys could turn on your video. If you guys out in the audience have questions, again, use the Q&A button. We'll be monitoring that. So let's let the panel get the first shot. What did you guys think? Do you have any questions about what I presented? Any clarifications, additions, enhancements, things you didn't agree with, or what have you?
I think just picking up, Wayne, on the fundamental question of, where do you start? I think in our view, there's two pieces to this. The first one is it's all about philosophy. DataOps is not a technological solution. There is clearly technology involved, and you went through some of the systems that you would need. But just like DevOps before it, and infrastructure as code, and SecOps, and the various other ops that have happened, it's first and foremost, it's about a different way of thinking and doing business. And you have to embrace that. No one ever got DevOps by deploying a CI/CD tool. You needed a CI/CD tool, but you had to understand what DevOps meant and what you were trying to do with it. So one of the things that we've worked with Wayne on, and Kent Graziano at Snowflake on, is the truedataops.org, which kind of enshrines some of the philosophy about how we think people should be thinking about the DataOps problem. I think the other thing that you mentioned, which was interesting, was you mentioned the single version of the truth. And you mentioned code repositories. Most people would not be surprised to say, okay, well, I'm moving things into a code repository like SVN or most recently Git. I think a key element of that is that it's not just about having a single version of the truth, but it's about moving that source of truth. So if you think about people that have done this fantastically well for decades now, the Netflixes and the Facebooks and the eBays of the world, if you go to any of those companies and say, tell me your source of truth, they won't give you access to one of their web servers. Those are just engines. They're ephemeral. They come and go. They'll give you access to their code repository. You go to almost any organization in the world that isn't doing DataOps and say, tell me your source of truth, they'll give you a username and password for the data warehouse. Until you get to the point of moving your source of truth out of the data warehouse and into a code repository, I don't think you'll get any of the benefits of DataOps. The data warehouse, the data platform, is an incredibly powerful engine, but it's like a web server in the web world. It's something that you project your source of truth onto, not a place you store your source of truth. And that's the biggest mindset change.
Right. So you agree with that statement I made that, treat your data as code stored in a repository, stored logic in the repository. That was a little radical statement for our crew. So I'm eager to hear what the rest of the gang think of that maybe the single version of truth is not in your data warehouse, but it's actually in your metadata that might be stored in a Git repository. Any thoughts?
Well, I think you need both. This is Jed. And obviously you need the data to be able to use anything in the metadata to process the data, right? But I'd like to back up with a couple of questions that have come up from the Q&A box that are a bit more fundamental, and perhaps we can answer that question and then go to where Guy is. And I think that's a good place to go. But how do we get there from where we are? And the questions are, do we still need data models? I mean, we've got DataOps, yes, and we have code repositories. Do we still need a data model? And I'd like to throw that out to the panelists to discuss.
I think it's obvious that we sometimes need data models. This is Dave. If we're going to try to structure data, if we're going to try to provide data that we cast as a single version of the truth. And by the way, the contrarian in me says single version of the truth is a myth that will never be fully realized. But setting that aside, if we're going to try to deliver data that many people use and reuse and share, we have to do some design around that, and data modeling is our most mature design method. Now, the way we model may be different because we don't have to put together a data modeling phase. We can model as we develop, as we discover data requirements, just like we do in agile practices for building databases. We still need them, we just get there differently.
That's interesting, Dave. How do you build a model incrementally? Is it like we used to say, you build a data warehouse one data mart at a time, and you just kind of build on that base and you just keep conforming stuff as you go along? Or are you talking about something completely different?
We've been building data models incrementally since the beginning of time. Somewhere in these bookcases behind me are the original Peter Chen papers out of Louisiana State University on entity relationship modeling from somewhere in the 1970s. And I could dig into those papers and find the places where Chen talks about how you have to go a step at a time and discover the nature and the shape of your data and represent it. So if you're going to build data models incrementally, the fundamental skill is refactoring. Reflect what you know at any given point in time. And then when you have more knowledge, go back and refactor your data model to account for the new knowledge.
Yeah.
And I think that's something, I mean, my background for 20 years was running software development organizations, and that's something the software development world started doing 20 years ago. You know, back 20 years ago, we built huge UML diagrams and we did whole enterprise architecture phases before we wrote the first line of code. Nobody does that anymore. That's, you know, that's yesterday's news, and the reason being we had to do that because the cost of change and refactoring used to be very, very high. So you had to get it right first time. It's the same with data. If the cost of refactoring and change and the time taken is very, very high, you've got to spend a bunch of upfront time to get it right. If the cost of refactoring is very low, if the time to refactor is minutes, then it doesn't make sense to spend that upfront time because you're going to get it wrong anyway. As Dave said, you know, you're never going to know everything. So get to a point where you've got a first sensible version, build it, and when you find out where it's wrong or where it needs to change, then change it. And if you can change that on a day-by-day basis, it's going to be far better than trying to build something up front.
And the truth is, even if you could get it perfect up front, the world is going to change around you and it won't be perfect a week from now.
Exactly.
So that's really what DataOps does. It allows you to change really fast to the point where you don't have to do all this upfront planning.
Yeah, Dewayne, this is Chris, and you know, I think it's about the management of high velocity change in order for your team to learn faster. And I think it's based in humility that, you know, we've all been in the field for a while and we actually don't know what our customers want. And if you can put things in front of them faster, and if you can iterate quicker and not kill your team and not create a lot of technical debt and not create an ungoverned nightmare, then you can succeed. And so what's behind those set of knots is a fundamental refusal to believe that there's choices. Because in a lot of technical systems and people who've grown up in data and analytics, you either do things fast or you break things. Either you take along in design or you build something crappy. And so those, you can, if you look at high functioning organizations, both in software and in manufacturing and in data, you don't have to have those choices. You know, you can have low errors in production. You can deploy faster. You can collaborate across different teams at a high rate, and all for the purpose of getting your team to learn more by putting more in front of your customer to get more feedback to iterate and improve. And so that you know, that refusal to accept the constraints that we thought we have may seem radical to a lot of people, but I actually think that's the heart of the idea of DataOps.
Chris, I agree with you and think that I'm talking over someone, I'm not quite sure who.
No, that was me, Kevin, go ahead.
Okay, so a lot of the DataOps discussion we've had so far, which I think is valid, is focused on software development practices. One of the ways to avoid bottlenecks, to reduce bottlenecks, is to automate wherever possible. And I think it's important for data teams and developer teams to recognize the opportunity to automate so much of the repetitive tasks related to creating and managing and adjusting data pipelines. If you can reduce or eliminate the burden on those data engineers, enable folks to focus on what needs to be customized, you can greatly reduce the amount of work and also the risk of error. So I think automation needs to play an important role when we're talking about data ops.
I think that's a really good point. And I think the other ways we reduce the workload, Wayne talked about componentizing. One of the things we can do to follow up on componentizing is reuse. And a lot of those components we build are reusable, but there's a big gap between reusable and reused. And DataOps needs to help us bridge that gap.
Yeah, that is a good point. In fact, I'm going to go to a quote from a guy from Intel, Greg Martinez, who said, we create reusable design patterns that enable us to create a data pipeline quickly, change it as needed, and maintain reliability and consistency of the data output. So reuse is really important, but I think the whole DataOps thing is do some work up front to standardize certain things, and the standards will allow you to go fast. Standard code, standard metadata, standard ways of storing things, standard tests. And once you have those things in place, you can go really quickly and automate things.
Yeah. Well, Wayne, you brought up the company that spends one sprint out of 4 refactoring, improving, and working on their process. And that's a very DataOps idea, that your process that you work in to deploy, to monitor production, to collaborate your team is a thing that's worthy of your attention and is actually worthy of 1/4. And that's actually the fact that 1/4 of your team is focused on the process to get technical features into production and improve them. That's actually a good ratio. And for some software teams, it's half the team isn't actually doing things that are related to the website or the database the website runs on. They're actually making the machine that makes the machine. And even from a career path perspective, a lot of us in data and analytics, well, we want to do the new model and the new viz, and we want to create the new schema, and that's the cool stuff. And deploying that or writing some tests against it, that's for sort of lesser beings. And I don't think that that's the right perspective. If the mental model I think we want to have is that the machine that makes the machine, the factory, the process people work in is actually much more important than the stuff they work on. Because if you can get that right, then the velocity at which people can work is much improved, and you can get away from the heroic age of I know everything and I know every part of the system, so I'm the only one who can touch it.
Let me interject, because what I meant when I said with every fourth sprint, all the development teams spend one sprint reviewing their processes and optimizing, improving them. I think you said something that's slightly different, which is that you have 1/4 of your team focused on the underlying platform and processes and how to improve and automate them. And maybe it's just 2 different ways to get to the same endpoint.
Yeah, I think it's 2 different ways. I mean, whether you have 1/4 of your team devoted or 1/4 of your time devoted, like for instance, the idea of automated tests. You build a visualization or a model or a schema and load it with data. I can't tell you how many people I talk to who put that stuff into production and just hope that the data that flows through it works.
That's the hope and pray strategy, right?
Yeah. And so we have this environment where it's all about hope and heroism. And hope, heroism, and the hair shirts of the problems that you have to wear from it. And it's not a tenable way to work. And that's why you find a lot of people who have gone into the field of data and analytics with high hopes are getting burned out. And my big fear is that in this recessionary environment, that teams are starting to get cut because they're not delivering on the value of analytics of any form.
Yeah, we've seen all of those 10 symptoms. Go ahead.
Well, Wayne, I think you need to set it up right. And all these technical things that we're talking about are very true. But a lot of times I've run into development managers or VPs of IT or business folks who don't understand the framing. And you quoted Gregorio. I'm going to quote you, Wayne. That long ago in a paper you published said that, well, this data ops thing is really a combination of DevOps, which is agile development, and all the things that Guy was talking about earlier, plus total quality management, plus lean and continuous improvement.
Yeah.
And if you put all those things together, the TQM, in this case, you're going fast with data ops, but any sports car that's going to go fast and go safely needs good brakes. So you need to have the testing we talked about and the total quality management built in, and also have continuous improvement. And I think those concepts, there you go, put it all together and say, hey, you can't just go fast and agile. Even if you do your reviews, you have to make sure that you're thinking about TQM, you have to build in the testing, and you have to have the continuous improvement in the learning. So there you go. A lot of people were saying that, can you do better, cheaper, and faster? The old adage was, and one of the questions was, you have to pick any two. Well, that's what we're getting away from. And we think that now we're proving that choice of choose 2 out of 3 is a false choice. You can have all 3 if you are thoughtful and you do it in a deliberate yet quick way.
Let me bounce back to your sports car analogy for a minute, Jed. And one of the basics there for doing it safely is you have a safe race course or a safe track. And that's some of what we have to do as a foundation for data ops is a safe track. And I'll tie that back to the Wayne and Chris discussion of a quarter your team, a quarter your time. I think it has to be a mix of both. You do have to spend some time, everybody involved has to spend some time thinking about the processes and the foundations, but you also have to dedicate some people to primarily being responsible for that. If that's not what your data architects are doing, what the hell are they doing?
Dave, you always ask those awkward questions.
I think there's another element to that, safe track. If you think about it from a data perspective, one of the things that I think the data world as a rule does really badly and needs to learn from the software world is the way that we create sandboxes for people to work in. From a software development perspective, it's just not even a question. I'm a developer, I create a feature branch, that's it. I've got a safe working environment, nothing I do can break anybody else's stuff, and nothing anyone else does can break my stuff. That's great for the source control that you're talking about, Wayne. Absolutely, we can branch our configuration, we can branch our code, we can branch our metadata. The challenge we have is we also have terabytes or petabytes of actual data to branch as well. And that's been one of the biggest challenges. Is it's easy to branch your code. How do you branch a petabytes worth of data? And that's actually one of the reasons I think this problem hasn't been solved until relatively recently. If you look at sort of modern cloud data platforms like Snowflake with things like zero copy clone, you now have the ability where you can say, right, as a developer, I'll create a feature branch of my configuration and code, and I can feature branch a terabyte data platform at the same time. And now I have a complete sandbox, my configuration, my code, my metadata, and a petabyte of real data that's isolated to me. That's my safe track. That's where I test a new car. That's where I make sure the brakes and everything work. And once it's been through all that rigorous testing, which of course is automated, then that car goes into production, which is me merging into develop and then QA and then production.
Yeah, that zero copy clone features is, I expect a lot of databases will copy that, so to speak, because it's very powerful. As you're not replicating data, you're just creating a clone of it in a new instance. And then you can do it for things like you said, as well as I believe you would use it also to move from create a development environment, a test environment, and a production environment on the full set of data.
Yep. I mean, the most advanced data organizations I've ever seen have got to the point where they say, yes, we can maintain a production, a QA, and a dev. And that on its own is tough, and a relatively small number of organizations do that. Until they get to true DataOps, I haven't seen a single organization that said, oh yeah, every time one of our developers works on even a small feature or a small enhancement, we spin up a complete copy of that petabytes worth of data for them to play about with. That just hasn't existed until the last year, 18 months, because the technology to support it hasn't existed.
So if we put this in the context of other forces at work in the enterprise, it's very interesting to keep in mind that data sources and data targets in the pipeline continue to change, and organizations continue to, despite their best efforts to consolidate, make their environments more heterogeneous and complex. So another dimension, I think, with DataOps is the ability to change platforms, potentially as part of a cloud migration, for example. and to stay agile in that sense, because as you start to learn about a certain workload, a certain analytics initiative that you're doing, you might need to optimize it on a different platform. And so I think there's a need to make sure that a lot of what we're talking about here is agile and mobile and can change platforms too.
Yeah, and that was the example I brought up from a discussion I had this morning, and they have some stuff on-prem and some stuff in Azure, and they have kind of a data flow that goes across on-prem and Azure across half a dozen different tools. And as you follow the bouncing ball of data across that system, one piece broke. And so they got an email from the VP saying my reports don't work. And imagine that's where I think the sense of dread of a lot of people in data and analytics come from, and what I felt. Because I ran teams and still run teams that deliver data on a daily basis, and it sucks when you come into the work in the morning and something didn't work and your boss found out before you did. And so how can you build a system where if there's a problem before your customer does? And it's even gotten more complicated, right? Because the amount of tools has gone way up. The amount of platforms to run those tools have gone way up. And yeah, they're all cool improvements, right? And we all love new technology, but fundamentally the amount of technology, it's the process that sits on top of that tech that you need to optimize. And and from an emotional standpoint, I just don't think it's acceptable to live where your QA staff is your customers, and they're the ones who are finding the problems.
So that brings up the whole question of communication and coordination, and makes me want to toss a question to Sean. So we've already seen how self-service disrupted data governance and kind of turned data governance upside down. What does DataOps mean for data governance?
Well, I think DataOps is really going to facilitate better data governance and data stewardship. So if we are building these pipelines with data governance considered at every step, and identify the risks for data quality, data privacy, things like that, incorporate stewardship and governance into the design, and include that in the training and the implementation plan, have those people engaged early on, have those stewards engaged early on, we're going to solve a lot of the problems before we go to deployment.
Okay, good answer.
Yeah, and I like that. And then, the people talk about continuous development, continuous integration, continuous deployment, CI/CD. And while that's good for an improvement point of view, building on Sean's point about communication, if you change the code and it changes the results, or it changes the implication or some of the nuance in the data, particularly in inferential statistics, you better communicate that upstairs, because CI/CD is going to be your enemy if the business people are surprised, particularly if they make a decision that turns out to be not so successful.
Would it be too bold to say that DataOps will put the data governance and data quality people out of work?
I don't think that's necessarily true. I think it'll just support the effort to make them more efficient at what they're doing. I think the lack of DataOps is one of the reasons I got into data governance in the first place, because the data pipelines and the analytics were being undermined by poor data and poor data processes. And so I think having this level of rigor in the development process and delivering the analytic solutions will only make governance easier by increasing awareness across the board and giving the team the ability to design things that are mature, that consider all of the aspects that data value could be undermined by process and data quality and things like that, and incorporate those controls and monitoring into the design.
Well, I would hope it would free up the data governance people to move into that new frontier of data governance that's so far not been explored enough, and that's data ethics.
Oh boy.
Everybody has like more time now.
That's like a different session altogether, I think.
Oh my goodness. I like to remind everybody that, hey, send your questions in if you have other questions you want us to discuss. And if this is not the type of thread that you were expecting, send us your questions along those lines that you would like to have us answer. So don't hesitate on that account.
Hey, Jed, I see one good question in here before we touch the ethics hot button. Greg said, you said faster, better, cheaper. Oh, the question just disappeared on me. But it basically was saying, usually Dr. Google says you can only get 2 out of those 3. How does DataOps give you all 3? Faster, better, cheaper.
I can take that, Wayne.
Okay.
I thought I already covered that one, quite frankly, but apparently I missed the mark.
Well, yeah, okay, I'll be quiet.
No, go ahead.
Why don't you say it again then?
I think that question was actually entered before your comments, Jed.
Yeah. You know, it's the slide that we're seeing right now is to be able to do better, faster, and cheaper, and not have the false choice of having to choose only 2.
Well, and if you standardize your processes and you're taking a holistic approach, then you're removing some of the bottlenecks to really being efficient and delivering things better, faster, cheaper. So you can, in fact, do all 3, but it requires having a standardized, repeatable process where your team isn't spending time at each step trying to figure out, well, how do I do this time? As opposed to just doing it and focusing on being innovative.
There's another question in the Q&A about how does idempotency affect DataOps pipelines, which is the very same point. I'd also say I think DataOps pipelines have to be by design idempotent. The whole question about you know, what happens if something goes wrong? What happens if something changes? What happens if something breaks? The whole point of a well-designed pipeline is it is idempotent. When in doubt, the answer is just run the pipeline again. Whatever broke, whatever went wrong, the answer is 99.9% of the time, just run the pipeline again. And I think you know you've arrived at really good DataOps when someone arrives at your desk or the VP says, hey, something isn't working, and you don't panic. If the answer is, you know, I'll run the pipeline and go for a long lunch, when you're that confident that your pipelines are good and repeatable and idempotent, you've arrived at DataOps. And that's where the software world is. Something breaks, just run the pipeline again. It'll sort itself out.
Well, that idempotent, that's a new word for me.
Idempotent. If something doesn't contribute, take it out. Essentially.
If you run the same pipeline again and again and again, it won't affect the end results. So a perfect example would be if you run a pipeline that just adds some new rows into a table. Every time you run that pipeline, it adds some more rows. It's not idempotent. You know, running that pipeline an extra time will make things wrong because adding extra rows. You know, you should be running it, and the goal of a pipeline should be to make the end artifact, the end result, look the way it should do. Whatever state it was in, you should be able to run the pipeline, and the end result should look the way it should do. And if it's already in that state, it'll do nothing.
Yeah, and those are terms that come from software engineering. And there's, I think there's a set of terms that may sound complicated, but what they really mean is you're in the complexity business. And so because you're dealing with these complex distributed systems that have lots of code running in lots of servers in lots of places, I think that's one of the big things that DataOps says is you run a software team. And maybe the software team has 4 or 5 different tools, but you're in managing that complexity. And one way is to think about things like idempotency or functional architectures or reuse, component architectures, sharing. But those things are what software teams have been doing for decades. And so just the fact that you have a nice UI doesn't make it go away. And there is no super tool that does everything in data and analytics, no matter what all the vendors say. And most people have multiple tools. And you know, most vendors are telling you the message that if you use just my tool, you'll be safe. And so given that there's a multi-tool world, and given that the tools themselves are the work that you do in that tool is in essence code, because you could put an if then else in Tableau or Alteryx or SQL or a model or a script, and you can decide which part of your architecture that if then else is going to live. But handling that complexity and thinking of yourself as a software organization, I think is helpful. And that's a different, and it's weird, like a lot of people join data and analytics. It's like you graduated from college and you took the right turn to go to data, and you took the left turn to go to software and IT. And you know, we all have the sort of the same technical backgrounds. We all talk alike, but there's really a different, there's a different mindset that comes out of it. And I think that's where
brings those two worlds together. And I think also you're saying that orchestration in a multi-tool world becomes really important, right?
Yeah, and in software, they actually talk about a different word they call observability. It's about being able to observe what happens in the system. And it's about orchestrating. And it's also in some ways about meta orchestrating, because you're orchestrating a whole bunch of tools, because the pipelines themselves that you create are not just one pipeline, but they're sets of pipelines running in lots of different tools. And so you've got this sort of pipeline of pipelines aspect that is hard to understand. And then if you look at it from a holistic standpoint, big corporations have hundreds, if not thousands, of pipelines running at any time. And as those pipelines are connected together, they give value to end customers. But the pipelines themselves are owned by different parts of the organization. You may have self-service teams working on one, a central warehouse team working on the other, and the sort of Hatfields, McCoys, centralization versus freedom make it also really complicated to do work. And that's one of the major differences between DevOps and DataOps in that regard.
I have to ask a stupid question because most of us have lived in the BI data warehousing world for way too long. We never talked about pipelines until the last couple of years. But I guess what we've been doing all along with ETL is a pipeline, right? Are we all in agreement on that?
Absolutely.
That's
Just
the
one
most
of
basic design pattern.
Right. Yeah,
I think it's a little bit broader than that. I think ETL or ELT, it can be part of a pipeline, but I think a pipeline in a modern environment can be a lot more than that. It's not just moving the data, it's not just, it's also transforming the data, but it could even be at the consumption side. It could be, now I've got some new data or some updated data, it could be triggering a machine learning model to relearn or regenerate. So I think ETL, ELT was a pipeline, but the definition of pipeline has got a fair bit broader. And ultimately, if you want to get most of the benefits of DataOps, you need to look at a pretty end-to-end view.
Okay.
So that brings up an interesting question. Do you consider the presentation and visualization of data as part of the pipeline, and how does that fit into DataOps?
Well, from my perspective, I think you do, right? Because the problem in any visualization tool is that you can do data work. You can build an if then else in Tableau in a calculated field. And a lot of data and a lot of BI teams actually, even back in Cognos, are writing a bunch of SQL queries behind their report. And so there is complexity in code in that visualization layer. And so, and that's owned by different parts of people in the value chain. But yet when your VP sees a report, they don't know that it was the if then else was built in Tableau or Alteryx or the database or the script or the model. They just know it's wrong. And now you've got to fix it.
Yeah, and from a governance perspective, I look at it from an end-to-end perspective, because there's opportunity for errors in that entire data value chain, right up to the person who's interpreting the report. So, yeah, from my perspective, it would be the full end-to-end process.
Yeah, and Jeb made the point earlier, if you change the semantic meaning of something, but upstream parts of the organization, consumers of the data, weren't aware of it, then you've got real problems. So ultimately, when you're making semantic changes to anything that's going on, you need to be changing your data and you need to be changing your presentation analytics at the same time. So by definition, they have to be versioned and controlled in the same system. Otherwise, you could never make those sort of changes.
Yeah. And that's where the collaboration and communication comes in, making sure everybody's aware of anything that will impact.
Yeah, but it's a bit different, because it's not just, because how do you get people aware? Well, one way is, to have a meeting or a Zoom and we talk with each other and send emails. And, that's fine. I just know my technical people, and we don't like to have meetings. And I think the way you collaborate ultimately is you give them a button saying, I'm going to change this. What do I break? What shit breaks when I change the schema? And is it which reports, which things? And I think we need that, because I want that. I want to know what breaks. And you've got this mesh of artifacts that are running in a way across the network. How can you tell if something breaks? And that's where we end up with a lot of Hatfields, McCoys, and IT doesn't let self-serve. And the reality is that you should have both, and you just need to be able to make a change and know if something's going to break. and not have 3 meetings and not have the smartest person in the company, bless their voodoo on it in a technology review board.
All right, let's take let's make a little change here, or change things up. Deb, let's do another poll here quickly. And then I want to ask a question that got a second nomination here.
Yeah, I see a couple good ones in there too, Wayne.
Yeah. All right, for all of you out in the audience, what DataOps tools do you use? We've been talking about those. Code repository like Git, CI/CD tools like Jenkins, performance monitoring tool for your apps and your infrastructure, orchestration tool like Airflow, configuration repository. You can keep track of all your releases for all your software tools, container management software, continuous testing tool or automated testing, and other. So you can check as many of those as you are using right now. This one will be kind of interesting. We'll give you a little bit more time here. And then there was a question, I didn't quite understand it completely, but I think people are asking, do we need new ETL, ELT tools to support DataOps in data warehousing projects? So let's hold that for a second. All right, so hopefully you're all finished answering this question. Deb, why don't you close that and show us the results? I bet Git comes to the top. Yep. Git comes to the top, followed by CI/CD. Yeah. Performance, and then performance monitoring. Yeah. So widespread use of these tools, at least the top 3, which is good.
Sad that testing is rated so low.
Yeah, and I know from talking with you, Chris, that the testing is like the key thing. And I know from talking to Greg at Intel that, in fact, I'm going to put up a quote from Greg. Deb, if you could close that. Yeah, he had another quote here. This team is really doing a lot of good work in DataOps. Here it is. Test automation is a huge part of what we do. Without it, we can't maintain a high level of quality at the scale and speed with which we operate. We have more than 1,000 tests in our test automation framework. That's, Chris, you can probably tell us if that's good or bad. And we keep adding tests all the time. We are only as good as our test practices, and we strive to improve here.
Yeah, and there's a dual, the word test sometimes misleads people, because one aspect of tests is that you want to, it's more like a monitor or observe what's happening in production so that you don't get yelled at when things go wrong, because your data providers are always going to screw you over and a server is always going to go down. So you almost want to decorate your entire end-to-end pipeline with a bunch of tests or monitors, and you can have thousands of those, and our customers do. But then in development, in that case, you want to think of tests in a different way, more like functional tests, regression tests, unit tests. And it turns out that actually the intersection of those tests that you use in production and tests that you use in development is quite high. And you can reuse a lot of those tests that you've done. And so there's, in one case, the data changes, but your code is fixed. In the other case, your data is fixed, but your code varies. And so I think, thinking of testing and really saying, I want to get 20% of my time to develop automated testing is not a bad first start. And being able to, and that gives you the proof that things work. And it also gives you a great way when something goes wrong, because inevitably things are going to go wrong in analytics. So you can say to your customer, yep, it was wrong. Yep, it was our fault. And we put a test in, so it's not going to happen again.
And most of the clients that we work with, or at least that I've worked with, really struggle with testing. So anything we can do to streamline and automate testing for and make it repeatable, because you have to assume that just because it passes now, it's going to fail at some point. So just being able to have those control monitoring activities in place, like you said, is important.
There's a question in the Q&A, just to clarify, what's the difference between testing and monitoring? So as I define it, testing is about stopping bad stuff getting to production. Monitoring is about accepting that no matter how good a job you try and do at automated testing, you'll always ultimately fail. So if you think of organizations, I mean, Netflix are famous for this. Netflix split their time. They spend 70% of their time saying, we're going to write a great set of automated tests to try and prevent bad stuff from getting into production. But we're also going to acknowledge that ultimately we will fail. It's not possible to write perfect automated testing. Therefore, we'll spend 30% of our time monitoring production so that when something bad does sneak through, we catch it quickly and we can roll back quickly. So testing is about stopping bad stuff getting to production. Monitoring is about, on the rare occasion where it does happen, catch it quickly, catch it to the point Chris was making earlier, catch it before the business user sees it, catch it 3 minutes after it went live, roll it back, 3 minutes later, and then go away and have a cup of coffee and work out what went wrong.
What percentage of development tests, regression tests, unit tests, do you actually roll out into production and use in the monitoring phase? Or is that a whole different set of tests?
From my perspective, when you write a test, you're writing an assertion. You're saying something must be true, and it can be as simple as there must be at least this many rows in a table, or this column must be unique, or there must be some foreign referential integrity. You write that for development. But even when every time you run a pipeline, even though your code may not be changing, this is one of the differences between DevOps and DataOps. With DevOps, you've only got one thing that's moving. It's your code. It's your software. With DataOps, you've got two things that's moving. It's your code and configuration and the data itself. So those tests have to run every single time. Just because my code hasn't changed in a week, the data coming through my pipeline has changed. So I have to run those tests every single time I run data through, because it may well be that something on the source system changed, which broke one of my assertions. And then you get down to a fundamental question. What's better for the business? Is it data from 2 minutes ago that I know to be wrong or strongly suspect to be wrong, or is it data from 6 hours ago which I know to be correct? And in virtually all situations, customers say, I would much rather my business users being seeing data that's a little bit older that I know to be correct than data which is absolutely up to date, which I suspect has an issue. So this is about, you run those tests, and if those tests don't all pass, then you simply prevent promotion, you prevent the deployment of that final artifact.
So all the tests you build in development, you run in production.
Every single time.
And slightly different from Chris.
And I greatly appreciate the folks who have joined in their questions. And there's some other good ones there. For example, hey, everything we heard about DataOps sounds really great. Aren't there any downsides? And I don't know if we have the need to go into those.
Because that's a good question, Jed.
It is a great question.
Although you jumped on my question. So let's answer my question first. I think it was, how do all the tests you run in development run in production? I think that was the last one.
Yeah, right? and I think the answer is they have to. What's the downside of that? The simple downside is resources. But the point here is they're not people resources. Yeah, if that's a Word document with 50 pages, that's a big problem. If that's a set of 1,000 automated tests, what do I need? CPU cycles, compute resources.
Well,
what are compute cycles in the cloud? Elastic and cheap.
I thought I heard something that's slightly different from Chris, though.
Yeah, I think the majority of them you can share, but they need to be parameterized so that you can, scope their use. And so, I mean, and I don't think all of them, but our customers, it's in the 80-90% that they run in development and production. Development production.
Yeah, I think that's where the TQM and lean piece comes in as well. So if you do a risk assessment of what are the impact of certain things going wrong in production, and then bring forward those test scripts from dev for those areas that represent a higher risk, if there's issues with the data or the code, and implement those as monitoring activities.
All right, so let's finish with that last question, Jed, that you had, which was, say that one more time.
Hey, everything sounds great. What's not to like? There's no downside?
What are the downsides of DataOps?
I genuinely don't think there are downsides in the sense, is anybody going to turn around and say, well, you know what, in the software world, DevOps, it's got some issues. It is genuinely, as Chris was saying earlier, it's one of those things, we don't have to make the compromise. We don't have to choose 2 out of 3. I think the slight difference is it's not a downside, but there is a challenge. The challenge is not technological. The challenge is organizational and people. The challenge is there are people that have been doing this one way for 20 years, and we're now asking them to think differently. And a bunch of them are completely ready for that, and there'll be some people who aren't. I think all the challenges about deployment are organizational and people related, not technological.
Yeah, I think there's a certain amount of courage that is required to implement DataOps, because you have to stop and take the time to review what's going on in your environment and figure out ways to improve it. And everyone usually is so far behind the 8 ball that they don't want to stop. you know, that they feel they can't. They're putting out fires. How can we stop? But to do data ops, you have to have a team-wide commitment to stop and think, identify bottlenecks, figure out ways to improve them and implement them. And that takes time, you know, 1 out of every 4 sprints. So 2 weeks out of every 8 weeks or 10-week cycle, you're focusing on process improvement. That takes courage, I think. And I think that's the challenge.
Yeah. And
Therein
that's
lay the downside. And that is that so much of this discussion assumes that these data pipelines are being built by your data engineering team. And in many organizations today, 50, 60% of your data pipelines are being built by self-service data consumers using data prep tools. And how many of these self-service data pipelines should be operationalized compared to how many are being operationalized, and how many of these self-service data pipelines should reap the benefits of being componentized and reusable and standardized and so on. I think that's the gap we have yet to fill, is data ops meets self-service.
Yeah, and we found it's hard to convince, and we've done work with Alteryx and Tableau, but it's you know, it's hard enough to convince a data engineer and ETL engineer that they need to do test automation and deployment automation and environment management. It's harder to have you know, someone who's a self-service tool to think in this process way, and some do, some don't, but it's definitely they are laggards. But on the other hand, we've seen some movement from the centralized IT to try to give kind of environments wrapped in a bow to the self-service team, where they can put their code, they can do their work, and they can have some control over visibility. And maybe the centralized team is the one that operationalizes the Alteryx pipeline, or takes pieces of the pipeline and reconverts it into some other language that they know. And so that having that relationship between the two is hard.
So one thing I'm starting to see, Chris, and it harkens back to something you said earlier, is that the IT teams are trying to build automation platforms to support self-service and prevent the local teams from putting logic into BI tools without hamstringing them, like giving them a platform that makes it easier for them to build their mashups, not in Alteryx or not outside of the data environment, but inside the data platform, where it can then be monitored and reviewed and then promoted into a formal data mart or integrated formally into the data warehouse. So
well, I think that's the biggest challenge of DataOps. It almost goes back to my my junior year philosophy class and reading the Brothers Karamazov. Like, do you give people freedom, and are they going to screw things up, or are they going to excel? And some people think if you give people freedom, they're just going to screw things up, and you need a boot on their neck to control them. And other people think if you give people freedom, they do things in the right way. And self-service is freedom. And so you know, where you depend upon that line, I think is, and that's one of the biggest challenges of DataOps, is it does have a component that is about empowering people to do more. And you know, one of the ways that you should think about this is, can a person on your team who's just out of college and within their first week of work come in, change a pipeline, deploy it to production, and guarantee that they're not going to break anything?
And I think the final corollary to that is, so completely agree from a community perspective, but do it in the way that means your organization is sure that you're not breaking GDPR and PCI and PII regulations. So yes, you absolutely have to have that ability to do it in a very community way, but you still have to have the safety net, because there is so much regulation about data now that we have to be compliant with.
Yeah.
Well, we are going to let Guy have the last word here, because we are definitely over time, 5 minutes over. I want to thank everyone who's hung in there and listened to this Shop Talk webinar. I hope you enjoyed it. Please send us your feedback. Deb, maybe you can put up the last poll. Yeah, did you find this webinar a valuable use of your time? And any other comments or feedback you'd like to give us in the spirit of data ops and continuous improvement, we'd like to hear from you, how we can do better here. I certainly learned a lot here. I hope you did too. So thank you very much for your time. Thank you, panelists. It was a wonderful discussion. And we'll see you back here in a couple of weeks. Take care, everyone.